Good afternoon, everyone. So let's begin with the logistic regression session where we left last time. What all we have covered so far is we have understood the logic between relation between log and exponential. We understood why we are not using probability directly for model development purpose, why we are using a log of odds in logistic regression. This is the entire calculation that I had explained. And then by solving this log of odds, if we solve this entire equation, we come up with this probability formulae where we can then estimate the probability also. All these slides we have covered, and again, one of the simple reason logistic regression is used, because when we are trying to predict the probability has to be between 0 and 1, right? If we directly build a model with respect to probability, there will be a range which is minus infinity to plus infinity. But by converting it as a log odds function and then modeling for that, we are able to restrict the value of probability between 0 and 1. Then as any part of modeling, we have to first understand the business objective. Let me again reiterate, the business objective is we have got data where we have got where the bank executed a campaign to sell personal loans. Okay, in 1 month, the customers who were willing to take a loan and who responded, they are marked as 1, and those who did not take the loan or did not respond to the offer are marked as 0. So here you can see that there are some 1s and some 0s. Yeah, and some of the demographic variables that are available is age, gender, occupation, some behavioral variable like balance, number of credit transaction, and then a couple of more behavioral variables which is holding period and score. All these data we have integrated together and prepared our modeling data set using that join, and this is our final modeling data set that we have. Yeah, then once you have your data set, first is basically understanding the variables. So for categorical variables, we typically do frequency distribution, we do cross tabulation between two categorical variables. For continuous variable, we typically do percentile distribution. So summary is a very simple, fast function, easy function by which we quickly summarize all variables in one go. And then we can use quantile to get percentile distribution. We can use table to get frequency distribution. Based upon the distribution, specifically for continuous variable, we have to see whether there are outliers or not. And I mentioned that typically outlier treatment we do at P1 and P99 percentile. At P99 we typically tend to cap if there are outliers, and P1 is where we tend to floor if there are outliers on the lower side. Yeah. Then we saw imputation. How we can go about imputation. So there are various ways of imputing. One is like a mean value imputation, using information from related observation, imputation based on logical reasoning, or if we are not able to impute, then create a missing category as a separate category itself. Typically, techniques like k nearest neighbor is used for imputation. Typically, a linear regression technique is used if there is a continuous variable where the missing values are there. Then using those records where information is available, we'll build a linear regression model and then use the linear equation to impute the missing values. So there are various ways of imputation that we can use. These are all what we saw. Then we said, okay, we have done some missing value treatment, imputation, outliers, and all those things. I want to understand, of the many variables, which variables are important. Okay. Again, here I would like to mention that the sequence in which we are executing the steps need not always be that first I will do outlier treatment, then I will do information value. Someone may say I want to do information value first and then go about doing outlier treatment only for variables which are strong predictors rather than focus on everything. Okay, but definitely exploratory data analysis you will do before you do information value or outlier treatment. The reason why exploratory data analysis is done before you do information value or outlier treatment and other things is because if you have created a variable and that variable itself is completely wrong. For example, holding period. I know the range of holding period is between 1 to 30, 0 to 30 or 31, right? And from when I do exploratory data analysis, I come to see that the holding period value is coming anywhere between 0 to 100. So obviously the moment I see the range of that variable is out of what its permissible values, I am clear that that variable is wrongly created. So I'll correct that variable computation formula and rerun the code and create the right variable. As such, exploratory data analysis is always done before you go into outlier treatment, before you go into missing value imputation, before you run concepts like information value or visualization and pattern detection. That has to happen before. The rest of the things can happen depending upon the way you would like to do as per your convenience. Yeah. And again, there is no hard and fast rule that IV should be done only before you do outlier treatment. Outlier treatment should be done before you run IV. There is no hard and fast rule. Yeah. Now we saw IV. Why is IV used? IV is used to see which variables are significant variables. Information value helps to relatively rank the variables. Now there are many variables. Based upon the IV, I can say if the IV value is less than 0.03, I can say it is a very weak predictor variable. That variable may not be worth looking at. If something is between 0.03 to zero point 0.1, I may say it's a moderately weak. I may consider it. It may give a small lift in the overall model when I build. 0.1 to zero point 0.3 may be strong, zero point 0.3 to zero point 0.5 may be very strong, greater than zero point 0.5 is say suspicious and so forth. No. Yeah. So all those things we saw in IV. We have executed the codes till this level last time. So what I would do is I'll again do the same thing. I'll load my data set which I have already shared with you people. This is the data set. I suggest that all of you load the same data set which was sent over email. I'm sure you executed similar steps last time. We are not going to run all these data preparation steps because we saved our data frame in last execution. Summary, quantile, all of these things. This is summary, quantile. Uh, what I'll not do is I'll not run all of them, but yeah, I'll do this capping flooring code. I'll run again. I'm doing capping, and this was imputation part. So we know what value we are going to impute. So I'll directly run the imputation part of the code also. I've done imputation, and for categorical variable occupation also we will do that. We said that the missing category will type it as missing. So we have done missing imputation also. Okay. IV we have already executed. Let me run the IV code again. There is some point that I wanted to explain. So library dev tools, library weight of evidence, and this part of the code. So IV is getting computed. While IV is getting computed, what I am now going to explain. what I'm now going to explain is at times IV of a particular variable may come less, but you have a strong hypothesis that this variable should have been a strong predictor variable. In that case, you may want to dig deeper into that variable, and probably you may want to do some transformation also. Okay, that transformation is like creating a new derived variable, and after transformation probably you may end up with a new variable which is a better variable than the previous one. And when you now run IV for that variable, you will see that IV has improved. Okay, it is quite possible that can happen. It's just a matter of transformation. So what we are going to do, we are now going to focus on visualization. Okay, what I have given to you is a function which is for visualization. This entire function, let me take some time to explain it. Typically I would not like to explain code while we are doing analysis, but at the end of day you have to use tools like R or SAS, and you have to understand that you have to develop logics also. So what I'm doing, I'm writing a function here which takes a data frame as an input, which takes a column name which will say which column in that data frame is target, and I want to evaluate which variable against that target. Okay, so this data frame which I'm getting here, from that entire data frame all variables are not of importance, only this target and the variable is of importance. So what I'm doing is I'm taking that two columns out and creating a new temporary data frame. This data frame, for my convention in the rest of the code, what I'm saying is this variable, first variable, I'm renaming it to X variable, xvar, and using this syntax I'm renaming the target variable to target, because here whatever name may come, it may come as a flag. Assume in your data set target is not stored as target. Here fortunately in our data target is named as target, but if assume someone names it as flag, my code has to be such that it should run irrespective of what you are calling, right? So for that what I'm doing, I've created this temporary thing and then named it as a target. Yeah, and then I'm using a decile function which is already given up. You have used this decile function. This is a decile function. This decile function is basically a function which splits a given continuous variable into 10 buckets, and we use this code when we imputed holding period. When we imputed holding period, we use this decile function. So I'll just compile it because the second function makes use of this function. So this has to be compiled before I use the other function. Okay. So here I'm using now decile function and deciling the X variable, creating 10 buckets of a continuous variable and putting it in a column named decile. And then I'm aggregating the entire data using decile or using data table functions. So I'm casting this data frame. TMP is actually a data frame. Now I'm casting it to data table and saving it in another object named tempdt, temp data table. And then here if you see, the entire aggregation logic is written. I am finding which is the min value of that X variable, what is the max value, what is average, how many records are there, how many responders are there, how many non-responders are there. At decile level I'm aggregating the things. So by deciles is saying that aggregate these things by deciles. Then I'm computing range. There is a min value, there is a max value. So I'm saying min and max, min to max. So it will give me range. I'm computing in that decile how many responders are there. So how many response rate, what is response rate? That is number of responders divided by number of observation. And that response rate, I can say, is probability of customers in that decile. So I'm naming it as prob. I'm just setting the reordering the columns so that the columns comes in a right order. So I'm just using set call order. Using set call order, I'm reordering the columns, and then I'm doing some cumulative calculations also. Cum total, cum responders, cum non-responders, cum percentage, and so forth. And finally, I'm exporting, after doing all of these things, I'm exporting it to a file where the output folder path would be preset in some global variable. And here at the same time I'm displaying it also using view function. So this is the entire function. Let me select this entire function. This entire function. Control R. I have compiled the function. Is there any okay? So this is the entire function. Is there any error warnings? No error warnings. Yeah. So my function is already compiled. Now I'm going to call this function. As I said, output folder where I want all the output to be dumped. I am setting it as a global variable which I have used inside the function. So I'm saying that any output calculation that will happen has to go in this path. So I've declared that. In the function call, we said this function is called, I need to pass three parameters. One is the data frame. Second is which column is the target variable. So the target variable actually is target. So I'm going to pass that, and which column I want to evaluate with. So what I have done is, in one go, I would like to evaluate all the numeric variables. I don't want to keep calling this syntax. What I could have done is, I could have called this syntax like this also. I could have done this entire thing like this. Uh, this is a function which we defined, target, and this I could have said I want to do it for age. Okay. So if I would have written this, I would have executed this 3 lines of code. My visualization code that I have written will see the output soon. Whatever output I have written would have executed only for the age variable. So I'll run this. Object age not, oh sorry, I'll have to put it like this. Okay. Shift F and home. Could not find, oh sorry, I did not run these two steps. Library, data table, and library skills. Okay, these two are required in that. Let me call this again. Now this entire logic is executed. The entire table, when I execute this entire logic, the entire table code is generated here. At the same time, that file is also written here. If you see the timestamp 14:29 and current timestamp is also 14:30. So this file is generated 18th March 2017. It's generated now. Yeah. So if I open this file, this the entire thing that you see in the view is also written in the file. Now this kind of thing, assume you have got a data frame which has got 500 variables. Of the 500 variables, 450 variables are numeric variables. I already mentioned that when we are working, you will have these kind of data sets where there will be uh, so many variables. Okay, when you have so many variables, are you going to keep writing one line yourself? First age, the variables can be uh, number of credit transactions, number of debit transactions, number of all transactions. These are numbers. Parallelly, there will be amount variables. Total credit amount, total debit amount, total credit and debit amount. Now, debits can happen through ATM, debit can happen through mobile banking, debit can happen through net banking, debit can happen through a branch withdrawal, debit can happen through a check, debit can happen through wallet transaction. Now when you all having this, so you'll again have variables, number of ATM debits, number of net debits, number of mobile banking debits, again variables will be there, again corresponding amount. Now you can have variables saying number of transaction this month as a percentage of previous month, ratios, again variables will be there. When you start creating these variables, when you start thinking the data from multiple dimensions, you will end up creating some 200, 300, 500 variables. Now for all these variables, if you want to do this kind of output, what you will have to do is you will have to write the syntax like this. Now we have done it for age. So now I want to do for balance. I'll have to keep typing this way. I'll run this output I'll get. I'm still not gone into how to read those. Now I do this date modified. Now you see balance has come. Is there a way by which rather than me doing this manually, can it happen automated? See, scale will happen when you start thinking I'm doing this one by one. Can I do automated? The moment you start thinking can I automate and make it as an automated process rather than me writing manually, that time you will move up the ladder. Okay, so here what I have done is what I've done is I have using this syntax. I am taking all the columns which are numeric and putting them in a call list. So all the columns which are numeric, when I run this in my LRDF, which all columns are numeric, all of them have come here. Okay. After having got all of these columns, now what I am saying, I want to loop through them. I want to loop through them. So from I in 1 to length of call list. Length of call list will say how many variables are there. So 8. So 8 times loop this and keep each loop you call this function. This function which we wrote outside. Call this function, but now the question is how do I give these variable names? I can give these variable names by call list bracket index position. When I say call list 1, it will say target. When I say call list 2, it will say age. When I say call list 3, it balance. So I stands for index. I is the index. So I'm now looping it. When I loop this, sorry, my files, I have opened it, so it is given me error. I have to keep those files closed. So in the background, the loop got executed. Now if you see date modified, this CSV file you can see, all of this has got created with almost the same timestamp. Yeah. So this is how you automate it. The next level of this automation would be, on this you can call a automated Excel macro. And what that automated Excel macro will do is create from that data this kind of charts. Okay. So now I'm going to show how these charts are created. Everyone, I hope you who have downloaded your lrdf.r data which I had sent over email and put it in some folder path. This was sent last week, not today. Okay? That folder path you have to put here in setwd. First you have to set that folder path and then you have to load it, and then you have to run the view to see whether you have loaded the file properly. After having run the view, you will see this kind of a output where these imputed will not come because I run the imputed steps afterwards, but other columns till holding period all the columns will be available. All of you execute these three commands and let me know once you are done. After you have imported it, we'll just directly move to these steps. This one, 73, where we have to cap. We already did this capping thing. We learned it last week. So move to line 73, 74, do the capping of balance variable. Okay, done. After capping the balance variable, we will now move to decile function. While we are moving down, just select this function and compile it also. Compile the decile function because we are going to make use of it later. After having compiled the decile function, we have to impute the holding period. We saw how imputation is done. So logic I'm not going to explain, but run this line 25, 125, 126 where holding period imputation is given. After imputing holding period, we had also analyzed occupation variable, and then we said we will create a separate missing category for occupation, and so imputed the occupation also. Yeah. After having done all of this, basically when you do view LRDF again, you will see this balance capped, holding period imputed, occupation imputed, these three variables coming up. Line 146, 147. Okay, so we have done imputation. Then what you have to do is load the DevTools library. So library DevTools, then you have to load WOE package. No, WOE is not required, but anyways, load it. And then I had run this this entire thing to just to get the IV values. So we'll see those IV values later on, but I had executed that to see the IV values. Then you have to run the library data.table, library scales also, because data.table is used in the function which is just after these two library syntax. And then we have to compile this function. Business visualization, BizWiz is business visualization. So we have to compile this function. So it starts from 193 and 183 and it goes on till 227. So we have to compile this function. After having compiled the function, you have to set the output folder. This code is going to create output for visualization purpose. The folder path that you have to set, this is a folder path which is available in my machine. You need to set an appropriate folder path which is available with you in your machine, because output of the BizWiz function, in the last step we are writing this statement, right? And here we are saying write it where? We are saying write it in a output folder path. This path is what we are saying. So this folder path should be there in your machine. Yeah. And target, in my data set, this basically LRDF, the target column is named as target. Quite possibly is some other data you are evaluating, that target is not named as target, it is named as flag. So you will have to, in that case, you will have to say target variable name is equal to flag. Yeah, I explained this logic. So here, compile these two things. You have to select them and run. And I already explained that we can execute this syntax one by one for each variable, but I don't want to run this one by one. I want to execute it for all the variables. So from call list till this for loop, you have to select and then run this entire syntax. And after having executed this entire syntax, you have to go in your this folder. After having executed the command, you have to go in your folder, whatever folder path you gave here, and in that folder you should be able to see these CSVs, the top, all these CSVs. Some 8 CSVs should be generated in your folder path. Once all of you have done, let me know. So once you have run these functions, you would have got this kind of outputs. Let me explain that in industry, I have done semi-automation. In industry, once this is dumped, on top of that, typically macros are also written, Excel macros. Excel macro would execute on it, on each of these CSVs. And after having executed the macro, this kind of graph would automatically create. So if there are 500 variables, we don't keep typing one variable, open the graph, create the data, then make the graph manually. No. All automations are done, because these are otherwise monotonous work. What is our work as a business analyst? Our work as a business analyst is to find patterns, visualize things. If our time is going to be spent in writing this monotonous work of dumping each CSV file one at a time, and then open each CSV file and create each chart one at a time, is your mind going to go more technical way, or is your mind going to go more business way? The objective is, when technical thing is done, do technical. But when you're starting to focus on the business aspect, which is pattern detection, trend identification, visualization, your mind should be focused to see where there is a pattern, where there is a bright spot, where there is an opportunity. At that time, you are not supposed to be thinking technical, right? So that's why we demarcate these two activities. Firstly, do complete automation, and then do complete business understanding, business view of looking at things. Yeah. So let me now explain how do we go about creating these charts. So this is a ready-made chart which I have already created. Let me start from scratch. This is my CSV file. I take this. Now here, let me explain all the columns for once. What I did was, using that automated code, that data which is looking like this, let me run the view command for LRDF. Now this and age and target, My focus currently is between age and target. Let me sort this data. So here I've got all 21, 21, 21, and then 22, 22, 22. And in each 21, there will be certain customers who are responders. In 22, there will be certain customers who are responders. In 25, there are certain responders and all those things. Can I see trend like this? If I just have these two columns, some 14,000 observations are, 20,000 observations are there. Do I see trend? I cannot. I can see trend only if I aggregate this data at certain level. Okay. If you simply plot a graph of age versus target also, you will not get the trend. What will happen if you plot a graph of age versus target? You will get dots coming at 0 and dots coming at 1. Because the values are 0 and 1 only. Age will be x-axis. Y-axis is 0 and 1. Y-axis, there are only two possible values, 0 and 1. So you will have see, if you simply visualize this graph, you will see dots coming at 0 and 1 only. There will be no dots in between. So to see the trend, you have to aggregate things at certain level. So what the function of visualization did is, this age, it split it into 10 buckets. And then in each bucket, it saw how many responders are there and how many observations are there. Okay, so if you see this Excel, what I'm showing here, I split it into 10 buckets. The first bucket is 21 to 25, 26 to 28, 28 to 30, 29 to 31. This is automatically decided now using the decile function.
But 21 to 25 is 4 again.
Each of them has got approximately 10 percentage of data.
So we don't have to do anything in that bucket. Like
automatically, the code is written that approximately in each bucket. Code we have to write.
What is it for?
We executed the decile function code. This decile function code we executed. This decile is partitioning at 0.1 level. 0.1 is 10%. It is written. Okay. For now, let's not go on to technical element. For now, let's not go into technical. Just accept that there is a code which has done this thing. So this code has split it into 10. So it has decided what is the min max. And again, I have computed the average of this range also. Then I've said how many observations are there in that range. Of that, how many responders are there? How many non-responders are there? So this is non-responder, this is responder. And what is the probability? That is response rate. Response rate is basically how many responders are there out of this total. So if I do ratio of this by this, is this much. This is the calculation. I can do this 55 divided by 178 for 3.08. So this is the calculation. So then this is the total, the cumulatives, all those things. Now I'll not go and explain all these things now. I'll skip it for future. But for now, my important is this is range. How many cases are there in each of these ranges? And what is the success rate for those buckets? In 21 to 25, if I make 100 offers, 3 customers respond. In 41 to 44, if I make 100 offers, 8 are responding. That is more important at this point of time. So these 3 columns is important for my visualization. Okay, so I'll take these 3 points. I will now do insert. I want to make a chart. So I'll take a chart, bar chart. So here, this is basically count. The moment I selected, it says me count. There is another graph also which is not seen here because the numbers are small, which is this. Because the numbers are so small compared to 1784, this is not coming visible. Can you see these dots? So what I'll do, I'll change the chart. I'll change the chart series, and I'll say show it on a secondary axis. Okay, I have now moved it to a secondary axis. But again, I don't want to see this and this, because this is representing, blue is representing count and this orange is representing response rate. I don't want to stack them one above the other. So what I'm going to say is change the series chart type for the red one. And now I'm saying here it says, if you see this part, it says CNT as a clustered column, and it is it shown on secondary axis? No, there is no checkbox. Probability as a clustered column? No, I don't want it as a clustered column. I want it as something as a line. Okay, stacked line with markers. And it is shown on the secondary axis? Yes, I want it to be on secondary axis. Now when I see this, this is the graph I get. Now is the trends very visible? Let us blow it up. Let us add labels to it. Add data labels. I don't want these data labels coming here, so I want format data labels, and I want it coming at top, not at right, above. I have now the data labels coming at top. Okay, I want to name this axis. This axis I want to name it. So design, add element, chart element. So I'll say axis titles. This is my primary vertical axis. So I'll say it as hash customers. Yeah, I'll say that, and okay, done. Then I want to label this axis. What is this axis? Yeah, this axis is what? No, second axis, but what it is representing on secondary axis?
Number of response rate.
That is response rate. So secondary axis is showing me response rate, so I'll say add title axis, secondary vertical. So I'll say it is showing me response rate, right? What is this axis?
Age bucket.
Age buckets. So I'll say age buckets. Add axis title for primary horizontal. Age buckets. And what is this chart title? I can say age versus response rate. Yeah. So this becomes my chart. Border. I like this rounded borders. It gives a smooth finish. So I made it a rounded. This rounds at the corners. Okay. So this is my chart. Now can you see trend in this?
Yes.
Can you make one insight from this? What is that one insight that you can make from this? You are getting high response in 41 to 44 age segment. Yes. A very extreme low response at 21 to 25.
So if you conclusion is like if you want to offer this like you can start from 24 and until 48.
Yes, so I can, if I want to offer, then I can probably target somewhere around 31, 32 and go till 49, 50 something. Yes. So this is the trend. Now, in this chart, this is the chart. Now let us go back to our logistic regression scenario. I'm making this chart smaller now. What are we trying to build in a logistic regression? What we are trying to do, we are trying to establish a relationship in logistic regression. The relationship that we are trying to do is ln p divided by 1 minus p, right, as a function of age. This is what we are trying to prove in logistic regression. If this is what you are trying to prove in a logistic regression, So I need to have this ln p upon 1 minus p column. See this chart, what we call it as a business chart. This we call as a business visualization. And this is what we show to business people. If age will come as a final important variable in the model, I am going to show this chart to my client. But as a technical person, as a model developer, this is important for you also, but you need to see one more chart. What is that chart that you need to see is basically how this ln p upon 1 minus p changes with age. Okay, so let us compute ln p upon 1 minus p. So here I'll compute log odds. ln p upon 1 minus p is log odds. Yes, so let me compute a log odds. So this is equal to this divided by 1 minus this, that is log odds. Yeah. Now what we are trying to show is this as a function with age. Now which variable is giving me age information? Range cannot, because this is a continuous number. So I'm going now to going to take average, because what I have done is for each slab I also computed average. So I can consider that average number as a representative of slab. So what we are trying to now prove is a relationship between age and log odds. What is the equation of logistic regression? Equation of logistic regression is y. That y is nothing but ln p divided by 1 minus p is equal to alpha a plus b x. Okay, this is what we are trying to prove. A is intercept, b is beta estimate, x is the independent variable. In our case, x is age. So we are trying to prove a linear relation between this and this, which means if this is my x-axis and this is my y-axis, I want to see a scatter plot. A scatter plot helps you get a relationship. So now I'll draw a scatter plot. Insert a scatter plot. This is a scatter. Okay, let me take scatter. Here I've got the x-axis, age, and here I've got the log odds. Okay, now this graph, there are 10 dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now let us try to put a trend line. The trend line that we have to put is basically a linear trend line. Okay, I'll put a linear trend line and say I'll display the equation and R squared on this. Okay, so this is my chart. What R squared do we see here? 0.1104. Can I increase the font of this? Probably yes. What is R squared here? 0.11. What is R squared? What is R squared? R squared is coefficient of determination. What is R squared? Coefficient of determination. What does R squared explain? How much of the variance of y is explained by this data? and we would like to have R squared which is 0 0.6, 0 0.5, 0 0.7, 0 0.8, because higher the R squared, more you are able to explain. Now here, when you see this trend line, this point predicted, this is your predicted point. When in this trend line, this part is the predicted. Actual is this. It is very close. This is predicted. Actual is this. I can say it is still close. This is exact, very much nicely predicted. Here it is nicely predicted. Here there is a gap, but still nicely predicted. Here also okay. But what about this? Very wrongly predicted. These two dots are also okay. What about this? Very wrongly predicted. Because of these two dots, the entire R squared is problem, right? So now comes variable transformation. Now comes the problem of, now comes how to do variable transformation. Okay? All of you with me so far? This is the technical plot that we have to do for each variable. Log odds with respect to a continuous variable. Now when I see this trend, I can see some of the points are very nicely there. If this I could have got somewhere here, if it would have been rightly predicted and this also somewhere here, you would have noted this R squared would not be 0.11, it would be 0.56, 0.67, something of that kind. Yeah. And with that, you would have said that, okay, I can predict the log odds as a linear function of h. But now I cannot say log odds is a linear function of h. Again, it is very clear from the business trend also. Now let me go back to the business trend. I could have got this idea from a very much, I could have got this idea from the business trend also. See, if there would have been linear relationship, this graph, which is going like this, should have kept going like this. But what has happened, this graph has gone like this, and then it has come like this. The linear relationship is not there. Now there are two solutions to it. So in this case, we have to do variable transformation. There are two solutions to it. One is you convert this as categorical categories. Basically, you slab this variable. So I create one slab which is, this is one range. This is second range. This is third. This is fourth. This is fifth. And this is sixth. I create 6 categories. Now these 6 categories will become in the background. The moment you create categories, in the background these becomes dummy 10 variable. What is dummy 10 variable? Basically there will be 6 columns created. First column will be age less than 28. Which all customer will fall in that age? They will be marked as 1, others will fall marked as 0. Second column will be age 29 to 33. Who all is in that will be marked as 1 and others will be 0. Now each category becomes a column. Now you are establishing a relationship between this 1 0 with respect to target 1 0, and that will be a linear relationship, because in that case anyone who is at 0 will have a slightly higher propensity or lower propensity, and anyone who is at 1 will have 3% as propensity. So it's the dummy 1 0 will be linear, because here also there are 2 categories, there are also 2 categories. Yes, yes. So either this is one solution, which is you create this based on your trend. You convert them as categorical variables. So you convert one column saying that category one column only you have to create. You don't have to create 6 columns. Internally it will create 6 columns that you don't have to bother. So you have to now create only one column which is age buckets, and you have to say 21 to 28. Anyone who is in that, you have to put value 21, 28. That ranges that I have put, no, these. So this range 21 to 25 and 26 to 28, you have to say 21 to 28. Yeah, that is one solution. The other solution now, let me propose that.
But this is a false imputation.
Let me explain other solution. If I take a partition here, I put a mirror here. Assume there is a mirror. Is this a mirror-like reflection? Somewhat symmetric. If I can transform this age variable such that the dots which are here can come here, that is called variable transformation. That is called variable transform. So assume this is 41 to 44. So assume I take a cutoff at say 43. Assume I take a cutoff at 43. And now what I'll say, anyone who is 44, I'll say that customer's age is 42. Anyone who is 45, I'll say that customer age is 41. Anyone who is 46, I'll call him as 40. Anyone who is 47, I'll call as 39. I'll now create a new variable. Okay? So let us create a new variable now. Let us create a new variable and see how things would look if we create a new variable. So we need to now write some logic of variable transformation. Okay, so the logic what I'm writing, I know from that trend, and again because I know the data, so from that trend I'm taking this point as a cutoff of 43. It is range of 41 to 44. I'm taking cutoff as a 43 for taking mirror. From data I know that I should be taking 43 or 42. Okay, again from trend I can see that. So what logic I'm writing is, I'm creating a derived variable age, a new variable. As I said, whenever you do any transformation, never override the existing variable. So I'm creating a new variable. So I'm saying that if age is less than equal to 43, if this condition is true, then keep age as it is. I don't have any issue with that. Else, this is if else code. So if this condition is true, this will happen. But if the condition is not true, which means age is greater than 43, so I'm saying 43 minus. Now how much it is higher? So if it is, say, assume the value comes 44. So 44 minus 43 will be 1. So 43 minus 1, 42. If it is 45, what will be? 45 minus 43, 2. So 43 minus 2, 41. So that's the logic I have written. Now let's run this. So a new derived variable age has got created. Now let us do this visualization for this derived variable age. So here I now say dv underscore age. Yeah, it's in the same data set. This age has come. So let's see this derived variable. You can see this derived variable has got created. Yeah. And if you see the if I just do sorting, you see the maximum is now 43 only. So on this, we'll run this visualization code. Now this visualization is done. So my output again will have come here. So this is my new, I want to see the log odds, right? So we'll create log odds. I could have run this log odds also automation there only, which I'm doing calculation. I could have done this automation there only. Is equal to P divided by 1 minus P. Okay. And what we are trying to show relation between this age and log odds. I'll again do a scatter plot. So insert, I'll take a scatter plot. Yeah. So I'll take this scatter plot. Now when I see this scatter plot, and now I fit a trend line. Add trend line, linear, okay. And I also want to display the equation and intercept. Okay. Okay, I did not select that format trend line. I want to show, I don't want to set intercept as 0. I want to show the R squared. Can you see this R squared? 0.61, 0.11, and now 0.61. This is called variable transformation. In logistic regression, when we build the models, because the relation that we are trying to establish between y and x, that y is log odds and x is the independent, log odds and x has got a linear equation formula. We see this chart and we try to see from the chart the R squared. If the R squared is reasonably good, then that variable trend is proper. If the R squared is something of that kind, in that case this variable may not come as a strong predictor variable. Because of this, what it is trying to do, when you build a relationship, it would have tried to put this fit and these points will go out and they will not be predicted properly. This point will be under predicted, this point will be over predicted, and because of that your prediction will be poor. But when you do the transformation, now definitely this is under predicted, but relatively not much under predicted compared to the previous one. So this is a better fit compared to the previous one. And this is the important step which you have to do in logistic regression when you build models. Each variable which you bring in a model, you have to see this. Okay. Okay. The way to create the charts is, first I'm going to select the range, shift control arrow down, control, and then I am selecting the second column and then shift control arrow down. Again I am pressing control and then selecting the column prob, shift control arrow down. The three columns which are of importance to me, I've selected them. Then I'm saying insert and then I'm selecting a bar chart. The graph is done. If you see that in this graph at the bottom there are these small red bars. These red bars are actually for my probability column and the blue bars are for count. Because the value of count is so big and the probability values are so small, that's why they are not displaying. So what I have to do is, I'll select the blue bar graph. I'll click anywhere and you see this dots coming up. Yeah. Now I'll press my arrow key, up arrow key. When I press the up arrow key, the next trend, next graph gets selected, which is for the probability column. Now somewhere here close, I'll come and right click. And first thing what I'll do is I'll change the data series. In data series, I'm now going to say secondary. So my probability has gone on the secondary axis, but the graph is coming as tagged. I don't want this graph coming as stacked. So what I'll do is on this graph, again I'm going to right click and then say change series chart type. And now here I'm seeing count is a clustered column. Okay. Prob is basically clustered column. I don't want clustered column. I want something like a line. So I'm selecting one of these various options in line. So it says line, stacked line with markers, line with markers. So I'll say line with markers. And here you can see there is a secondary axis tick. Okay. And my graph is done. Then giving appropriate uh, labels. So what I can do is I can come here and say design. In design, add chart elements. It will say axis, titles, chart titles, and so forth. So I'll say axis. I want titles to be changed. So primary vertical, left y-axis is primary vertical. So I select that, and in this part I'll give a name to it. So this is my count customers. So hash customers, enter. Here you see the label has got changed. Then I'll say add chart element, again go to axis titles, and now I'll say secondary vertical, and now I type response rate. So this response rate has come. Add chart element, I want to say primary horizontal, which is age bucket. So I say age buckets. I want to give a main title, chart title. I can select that directly and type here, say age versus response rate. This becomes, I want labels to come on this. So I'll select this red graph anywhere. See, now here it is, a blue one is selected, the bars are selected. Now I click somewhere on the red line, the red is selected. I right click and say add data labels. Add data labels, add data labels. Okay. Labels have come. Now these labels I select. The moment I select labels, on here it says me where do you would like to have labels. Cancel. I would probably want right click on this labels and I'll say format data labels. The moment I say format data labels, I would like them to come above, so I move them above. Okay, this is the graph. I typically don't like a rectangular edges. I like a curved, so I say format chart area. In format chart area option, I get rounded corners. So my graph is done. With this, I don't want these two legends. This is called legends. I don't want the legends coming at bottom, so I'll right click on them, format legend. It gives me formatting options. I'll say top right. So legends have gone up. I'm not liking that also. So I'll say, let me put it top. So top has come here. Okay, top is better. Probably if I don't still like it, I can move it manually. Drag and drop. Okay. So this is the various formatting thing that we can do on the chart, and this is my chart is prepared. I can save it. It is a CSV file, so it will not get saved as a CSV, or it should not. So probably because it says that there is a probability data loss, because CSV contains comma separated values. Once you save it, open it, graph cannot be saved it. So I'll save as, I'll change it, and I'll say XLSX format. It will say, do you want to overwrite? Because I already have a file with that name, so I'll say overwrite it. Yes. There is already that file is opened. This file is already open. Let me cancel it. A file by that name is already open. Let me now save as, and save as a XLSX file. Save. Do you want to replace? Replace. Done. Now this is all about formatting and creating that double axis chart. To create the log odds, you have to first compute the log odds. So what is log odds? Log of p upon 1 minus p. So here I have done that. Hey, sorry, in this graph, sorry, I did not do ln. When I created this graph, I should have done ln p upon 1 minus p. So we have to compute this. Log odds. Okay. Now you computed the log odds, and then you have to, what I did was actually odds. I forgot ln thing. So now I select this and this. Now I'll say insert. If you want to see linear relationship, you have to do scatter. So scatter of this, and now when you see the scatter of these two things, now you have to fit a linear trend line. This is your x-axis, this is your y. Log odds is your y, so it is coming on the y-axis. So I need to fit a trend line. So add trend line, add trend line. Linear is what we want to fit. So I'll say display equation, yes. Display r squared, I'll say yes. So the r squared is coming as 0.1272. Let me increase the font of this. Okay. And the other graph that we had was transform variable. Here I need to again do log odds only. I forgot ln thing. Okay, I'll just change it. There will not be much change. Now when I do log odds, this r square is 0.6696. Earlier we got 0.11 and 0.6 something. We forgot log element. We have added log element. So you can clearly see that this is a better fitting trend for the derived variable of age. Okay, but for you now, all of you compute the, you create the chart for the age versus log odds. Yeah. Here you have to just create the chart and then add the trend line and r squared. Get this thing. This is basically a technical chart. We as business analysts are supposed to see this chart. Likewise, you have to create these charts for each and every variable. What I have done is I have already created it. So what I'm just going to show this. So now when you see these kind of visuals, the way you have to remember data is, when you see this visual, you have to remember, what you have to remember in this is, as number of transactions increases, response rate increases. Now if you see this trend, as number of transaction increases, response rate increases. As a business analyst, you should have your, before seeing this chart, you should have your own hypothesis. What is the trend that you are expecting? You could have said that I expect high response from low transacting customer. Now when you make this statement, I expect high response from low transacting customer, you have to give a reason why. Or if you are making a statement, I expect high response from high transacting customers, you have to give a reason why. And that is how you you develop your business acumen. When you're able to hypothesize why you are saying that I expect high response from high transacting customers, or why I expect high response from a low transacting customer, whatever is a statement, it's a hypothesis. End of day, by seeing this or by seeing the p-value and all those things, hypothesis will be validated or not validated. So now when I see this, when I make a statement, I expect high response from high transacting customers, because customers who transact more will be primary customers of the bank, and if there is any requirement for any product or services, those customers will first go to their primary bank. That is my hypothesis. So I'm saying transaction is involvement, and because they are involved with a particular bank, they will go to that bank. Someone who is not transacting or not involved, they will not come to that bank. Or probably someone who is not transacting is out of station, that's why he's not transacting. So that's why response expectation cannot be there. So something, some hypothesis by which you, because of which you are framing a statement, you should be able to justify. Okay. So here when I make this statement and I see that there is a high response from high transacting statement, I can visually say my hypothesis is validated. Then there is a scientific way, the p-value, CHAID, chi-square test, f-test, any test you can use. But visually, is it validated? Done. So if that is done, now if I see log odds of this also, so when I see this, I clearly see it is a very linear relationship. I need not do any transformation. But still we need to see whether it is a good linear relationship. So what I'll do is log odds, log of p divided by 1 minus p. For this log odds, I have to again use the average. I select that column, I select this column, and I have to use a scatter plot, not a line plot. The reason why I have to use a scatter plot is because this axis has got a range. In a line plot, irrespective of values, they come equidistant. 2, 5, 10, 20. They will come equidistant when you make a line plot. But when you make a scatter plot, 2 and 5, there is a difference of 3. They will be scaled accordingly. When I do this, and when I see this, add trend line, linear, display equation, and R squared. R square is 0.80. Reasonably nice. Do I need to do transformation? Probably no. I don't need to do any transformation on this. So there's no need of transformation. Oh, I can
Table you have to check this.
every variable which is significant, you have to do this. Okay. All significant variables which you are getting into the model. All significant variables which you are getting into the model, you have to create this chart. Okay. Let us see another graph. Balance. So here the hypothesis is those who have got high balances, they will not need personal loan. Those who have low balances will require loan. The hypothesis is validated from the visual graph. These are high balance segment. These are low balance segment. I can visually see that there is a less of loan requirement. Yeah. So here again I can see that here you see there is a plateau. This is flat. This is flat, and then this. Which means if I now make a R square of this, it's not going to come good. Okay. So let's make this also as R square. ln odds equal to ln p divided by 1 minus p. So I'll take average column and I'll take the log odds column, insert scatter plot. Now I'll say add trend line, linear, set a display equation, display R squared. It's still coming 0.80. Okay. So 0.80 is good enough, but still, despite 0.80 coming, I can clearly see in this visual chart these four dots actually are plateaus. The R square is coming 0.80, but here these four dots, there should not be any difference. If you build a model for this, what will happen? These four are going to impact the model. So what you may have, sometimes what you have to do is using the visual feel, you may now say rather than building this as a continuous variable, rather than bringing this as a continuous variable in the model, I will do categorization. I'll make this as one category. All of them is at 5% response rate. I'll make this as a second category. I'll make this as the third category, or probably this is also at 2%, 2%, only there is a slight blip. See, this slight blips you should ignore, because logically if the trend is with increasing balance, I'll have low response rate. Sometimes these slight blips may come. If you are so confident that this blip cannot be there, you should ignore this blip and then club them with the adjacent segments. Okay, and this becomes the last segment. So probably I can have one category, I can have this as second, I can have this as third, and I can have this as a fourth. You can merge it and make three also. Only thing that you have to remember is don't make categories which have got 1% base, 2% base. Small segments don't. Try to then club them with the adjacent one. Yeah. So here it will become a categorical variable age and three categories will become part of it. Okay. Let us see the another variable, holding period. So here it's very clear. It's plateaued. Right? So again, either I have to make, and this is complete linear. This is complete linear. So let us see the log odds graph. And there is a missing category also. There is a missing category also. Okay. For now, I'll not take the missing because it will not get plotted. And missing we already, this is not the imputed variable. So actually I should have computed this for holding period imputed. This one. Okay. I should have done this for this variable. Let me open this holding period imputed and let me create this log odds. In logistic regression, this patience has to be there. Now you cannot keep doing these kind of trends yourself. That's why you need automation. But patience of seeing the trends and ensuring the trend is in line. Sorry. Parul, in holding period there is no outlier. In balance, yeah, you should have done that graph of balance with respect to the capped one, not with the balanced one, because in the outlier will impact the average. So in the previous one, when I did it for balance, this outlier would have impacted the balance of this extreme one. So here this value is coming as, let us see, the value of this average is coming as 5,48,378. Okay, this actually what she said is right. I should see it with bal cap. In that case, this in this case it is coming very close to 5,48,000 only. But it could have been so that one outlier would have made this as 10 lakh also. If it would have become 10 lakh, my entire trend would be gone wrong. So here we should see balance with respect to bal capped, not the actual balance. That's the reason why we did capping. Yeah. So holding period, we do not have any capping, but we have imputation. So we are not going to use the actual holding period. We are going to use the imputed holding period. Yeah. So insert, and we'll again do this one. So here I get this trend, add trend line. Display equation on chart. Sorry, not set intercept. Display R squared. 0.96. Okay. Let me now just let me create a fictitious graph and show you something, some kind of transformation that we can do further. Okay. Various types of transformation that we do on variables. One is we saw for age. Second is log transformation. Sometimes we even do exponential transformation. If the curve would be opposite of log, we do exponential transformation. Sometimes we do square transformation. The variable is x, we'll make x square. Sometimes we may do square root transformation to fit a linear relation between y and x. And these transformations are all done by seeing the trend, and then you decide which transformation will be a better transformation to get a linear fit. Okay, so this is all about variable transformations in logistic regression, and this is one of the most important step when we do logistic regression predictive modeling. So Parul, which type of transformation, whether log, quadratic and all of this, based upon your trend, you will have to decide. Or if you probably search on internet, there would be someone who would have documented, wherein they would have showed you this trend, this is the type of chart you are getting, go for log transformation. If this is the type of chart you are getting, go for square transformation. If this is the type of chart you are getting, go for exponential transformation. So those document on internet would be available, or probably once you start developing these models, after seeing couple of these visualizations for a couple of projects, you will start realizing yourself, hey, this is the trend, my R square is not coming good. Let me try a log transformation of the X variable. With extra log transformation, you will see, okay, trend is fitting better. If you feel, no, it is not coming better with log transformation, should I do exponential? You will try. Initially, what will happen is, it will be based upon your trial and error. But then what will happen is you will start realizing, hey, if this is the trend I get, this trend could have been corrected by a log transformation. If this is the trend I get, this trend can be corrected by a square transformation. So those things is the art element. Now let me give one example. Coming back to our age, and this is one of my best example from a banking side, which I often give. In age, when we saw this trend, let me delete this graph. Here we clearly see R square is very bad. This is the trend. Once I came across this kind of a trend, and I had a particular variable, which is something, the trend was like this. And the variable was the hypothesis that I had. Customers who take personal loans will have more withdrawal from the account than what is getting deposited in the account. So I aggregated data for a month and I saw total withdrawal, there is debits, and total deposits, that is credits. Hypothesis is customers who withdraw more than deposit are more likely to take a loan. So the variable was debit, that is withdrawals, divided by credit amount, ratio of debit amount divided by credit amount. And when I have this, the trend was, and this point where the trend was coming, inflection was coming, this value was 1. This was 0. 0 debit divided by all credit. So the scenario is someone is debiting no amount, but there is a credit, 0. Someone who is debited and credited the same amount, 1. These are the people who are debited more. This is greater than 1 segment. These are the people who debited more than what they have deposited. But there the response is coming lower. You would have, because I explained transformation, seeing this, you would have said, hey, we learned this mirror, you have to take that mirror image, transform, a standard statistical process. Analytics is not just mathematics. It's a fusion of business also. Art. It's an art and science combination. And the art element comes from your domain knowledge. Here when I thought about it, I realized that first is how can I withdraw more money from my account? It is possible. I can withdraw more money from my account than what I credited. Probably I'm eating up my previous savings. In a given month, what I credit is not just what I can withdraw. If there is an opening balance, which is savings of my previous months, which is there as an opening balance. So the moment I changed this equation and made it is debit divided by credit in the month plus opening balance for the month. The first important change that happened is this greater than 1 segment went off. This value maximum was 1 now. The moment this segment went off, what happened is these customers which were wrongly coming here, actually all these also, because for them the ratio was wrongly computed. The moment all of that happened, the new graph that came up was something like this. one sharper than the previous one, because this was giving me more higher response rate compared to here. And definitely if there are more responders coming here, this graph cannot start from the same point. This graph actually became like this, and on the other extreme I get very low response rate. This graph is more stronger compared to the previous one. So when this trend became more sharp like this, you are able to have one segment where there is very high response rate and there is another segment where there is a very poor response rate. So just thinking that because I got this trend like this, I should just do mirror. No, think from business point of view also. Before you even think of mirror, a pure statistician would go with a mirror approach. But here we have to bring the domain element. So analytics, model development, and frankly speaking, this art and science combination of model development comes only in logistic regression. Any other technique you use, you will not get this fun, the joy of seeing the trend and then saying, hey, I transformed that trend. That joy you will not get with any other technique, because all the other techniques does all the machine learning element. Only logistic regression gives you this. And this is the only technique if you really want to learn business, understand business. This visualization phase and transformation phase is the only phase which can help you understand business better. Provided you see a trend, think about that trend, and then say, why is this trend coming like this? My hypothesis was this. Why it is not coming according to my hypothesis, and then play around with it. Okay. So that's all on visualization, trend identification. So once we have all of these things, we transform the variables. Now we go into the model development. Again, during model development, you may keep doing these iterations. It's not that model development is a one-step process. You have transformed it. Now after transformation, because I have entered into model development, I cannot go back to transformation. Transformation transformation, visualization, model development. Based after you transform variable, we saw after I transformed age, I again did visualization. When I saw age visualization, based upon age visualization, I thought of transformation. I came to transformation step. So it's a two-way process. Based on visualization, I'll now see which variable is important and I'll take them to model. Definitely IV is going to help. The visual is further helping me understand the IV thing better. So from visualization, I'll go into model development. So when we start modeling, from visuals, we'll see which variable may come strong. So we'll go to the model development. Now when we do model, some variable may not come what we expected, because I saw a particular trend and then I created categories. I created 3 categories. But when I create 3 categories and run the modeling process, one or two variable categories are not coming stable. So what will happen is, from modeling, you will again go to visual and say, hey, I created 3 categories. Should I create 4 categories? So from visual, you will again say, okay, I should have created 4 categories. So now visual says, okay, 4 categories. So you again go from, what happened? You from here, you go to this thing, transformation. So basically these 3 steps in the entire process, variable transformation, visualization, model development, these 3 will keep happening till you get your final model. Okay, make sense? Okay, great. So we have understood the visualization aspect and the importance of visualization, I hope. Now we'll move into the model development. Okay. Wait. Okay. So after you have done the visualization, then you enter into the model development stage. Now when you do the model development stage, typically you have to split the entire data into dev, val and holdout samples. Development sample is where you're going to build the model. Validation is on which you're going to validate the model that you have developed on dev sample. Once you have done dev val process and you are okay with the final model, you will test on a sample which is holdout. Holdout is a sample which is not seeing the regression process during the entire devel process. Okay. So to do that, what we are going to do is we are going to use, and the first thing what I'm doing is I'm making a copy of LRDF. The reason I'm making a copy of LRDF is during the process I'm going to make any changes. If I corrupt the data, I have a safe version. So I'm making a copy of that. Using RUnif, a random number generator, I'm generating a random column in this. So it is going to create a random number. When I view this data, you can see this random number is created. Now I'm going to split this into 50, 30, 20. 50 for dev sample, 30 for validation, 20 for holdout. So let me run that. So let us see how many rows are there. 50% we said, so it is almost close to 10,000 observation. Here we said 30, so it's close to 6,000, and this is close to 4,000. The numbers need not be exactly 4,000, 10,000 and 6,000. Again, let us see what is the target rate for each of them. Here it is 4.4, here it is 4.6 and 4.15. These are very close to each other. I'll go ahead and use this. I require some packages. I'm just loading it. Okay. Now we need to call we'll build a logistic model on the dev sample. So here, rather than putting a dot, let me do that. I'll start putting variable names individually. Target as a function of age plus. What are other variables? Let us just list all the variables. Call names, my data. So, okay. When I execute this command, the code was going to take a longer time. No. In this entire data, when I'm executing this command, there is a column which is cust ID. It's an identifier column. Cust ID should not be part of the variables, independent variables. So this is the first column. So I need to remove the first column. So I'll say comma -1. Okay. Now if you run this, so what you are saying is you want to build a target as a function of age, gender, balance, occupation, number of credit transaction, this, random again should not be there. Target is taken on the Y side. So it will automatically determine that target is on Y and all dots will be on the X. So this 11, 12, 13, 14, 15. So I need to skip two columns, which is these are the two columns I have to skip. Okay. Why is this errors coming? Unmatched open brackets. Oh, gone. Okay. Now it is there. So now we'll build this model. Let me save this code also. Okay. Model is built. Okay. If you want to see what is the model looking like, we'll use this summary function. This is the kind of output we'll get. Now in this model, all the variables that we have passed has come as part of the model. No, we are not supposed to take all the variables. We are not supposed to. I've just run it. You are not supposed to take all the variables, but I'm just running it. So now when I'm running it, it says me age. Age p-value is 0.386. What is the null hypothesis statement? Assume I have null hypothesis with respect to my p-value I would like to have as 0.0001. I want variables to come at 99.999, 99.999 significance level, confidence. Okay. The way null hypothesis is framed. Null hypothesis is always framed like this. Independent variable does not impact the dependent variable. There is no relation between dependent variable and independent variable. Alternate hypothesis is always framed as there is a relationship between the y and x. There is a relation between the dependent and the independent variable. Okay. Now, if my alpha threshold for the hypothesis is 0.05, let's assume 0.05, which means I want to accept variables which is 95% confidence or above. Yeah. Here my age p-value, this is p-value, this PR, okay, this is actually p-values. This column captures the p-value. If my p-value is coming as 0.386, what it means is this 0.386 is greater than 0.05 and my alpha threshold is 0.05. If it is greater, then you will say null hypothesis may be accepted. If the p-value is more than the alpha threshold that you are setting for yourself as a significance, in that case null hypothesis may be accepted. Now when you say null hypothesis may be accepted, what is null hypothesis? There is no relationship, which means our target is not impacted by age. Yeah. which means this variable is not significant. This variable is not significant. Once you have established that this variable is not significant, what are you supposed to do? Drop that variable. Now let's see gender, 0.55. Again, gender is not coming significant. Balance is also not coming significant. So if this is the kind of output I get, should I drop all the variables together? No. When you're doing this model development, you have to iteratively drop variables. Now we know for age, we created a corresponding variable which is div age, which is coming at least some significance level. If not 0.05, but it is very 0.02. This is 0.38 vis-a-vis 0.02. Yeah? Which means I can easily drop this variable. Again, anyways, I have a derived variable of it. Now let's see this occupation. This occupation, when we had this actual occupation, okay, why is this occupation imputed having blanks? Let us just see why this occupation imputed has got blanks, and HP imputed also has got blanks. The imputed variable should have got the proper values. Let us just see what happened. Summary of this. When I run summary of this, what it is saying. HP imputed is proper, no issue. Holding period has got NAs, okay, no issue. Occupation, no, occupation, this and occupation has got corrupted. Somewhere there has been a data corruption. Let us just recreate this data set immediately. Okay, so we have corrected the data set, and occupation, which was showing some of these things, what we have done is we have casted it to factor. Okay. Yeah. Now let's get into our model development stage. Summary of my logic. Coming back to this. Okay. So here we see that age is not important. So based upon p-value, we are going to drop age. Then we see that gender, again gender is also not important. So we'll drop gender also. So as a first step, rather than dropping all variables, and again we see occupation, there are lots of these things coming up. So let's see why. Oh, random number. Why is random number coming up? We dropped random, right? We dropped random. Let us see. Call names. Call names, my data. 11th column, 12th column, 13th, 14th. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, 14th. Okay. In our code, 15. Rest all columns are right. You get HP imputed, val cap, and occupation imputed. Okay. So we have all of those columns. So let us run this without random number now. Okay. So this is the output. We are going to see that's HP imputed and this NA is, they should not come as NA. We'll see why it is coming NA later. For now, let's focus on the interpretation. So here, what we see, this age is not important. So what we'll do is drop this variable first. Okay. So as an iteration now, gender is there. So what we'll do is, instead of putting a dot, we'll now start putting variable names. Gender. Easy way out is attach. Attach, now we are building model on which data? My data.dev, right? So you say attach my data.dev. Now gender plus, but there is no point of attach also because yeah, we are writing all the column names.
So like in attach what we are doing.
We could have directly referred to column names. Anyways, we are referring column names directly. I want that auto prompt to come. That's the reason I was trying to attach. Summary my data. Oh, sorry, not summary. Call names my data. Yeah, I want to copy the column's name directly. Balance, okay, plus balance plus number of credit transactions plus occupation, but occupation has got missing value, so I'll skip occupation. Score plus holding period. So holding period, I'll directly take imputed one. We'll see whether it is giving problem. So these are the 5 variables. Okay. Any other variable? Age we have dropped. Gender we are considering. Balance we are considering. Occupation we have not considered. No, occupation imputed, let me take it. We'll see if there is any problem, we'll see it. Okay. Now we run that. Summary, my logic. Now that problem has gone because there were 2 variables having similar values. So that's the reason one of the variable was not getting its importance. So now when you see that gender is not important, balance is coming significant, number of credit transaction is coming significant, score is coming significant, HP imputed is coming significant, occupation, all these categories are coming significant except this one. When there are categorical variables, it is quite possible one of the category may not come significant. So there is no problem with it. Okay, you can ignore it. You should not see that, okay, if all the 4 categories come significant, then only I'll consider them. It's okay. Yeah. So here one of the category is not significant, I'll ignore. But gender, if you see, both of them are insignificant. Now, how many categories are there in gender? 3. Male, female, others. When there are 3 categories, in categorical variable, one of the categories is considered as a reference baseline. So the beta estimate of that is considered 0. Beta estimate of that is considered 0 in R. In SAS, it is not that way. In SAS, there is some other logic of arriving at the beta estimate of the reference baseline. For R, the beta estimate of the reference is 0. Okay. So here, gender, here for gender, I'll drop gender variable in this iteration. Okay. So let us run this code again. Gender is dropped. Model is again built. Summary. So here balance, number of credit transaction, score, all of them are significant. Now how do you start interpreting whether these estimates are right or wrong? What is the estimate of balance? Negative. Okay, it is negative. Let us see the trend of balance. This is the bal cap. Again, we got balance variable. In this, we should not get balance. We should have got bal cap. So what is the exact spelling of it? Bal underscore cap. So let me run this with bal cap. Okay. So here we have run the iteration again. This is negative. What is the trend of balance? I'll just directly see the trend of balance only. What is the trend of this? The trend is with increasing balance, response rate is decreasing. So now just assume it is a single variable logistic regression. Y is equal to alpha plus beta x. There is some alpha which is constant and beta. Now would you like the y which is log odds? Would you like this probability to increase with increase in balance, or as per the trend, do you see this probability should decrease with balance? Increasing balance, it should decrease. If balance increases and probability decreases, which means their inverse relationship, in that case the sign of the beta should come negative. This is the trend. Is my sign negative? Sign is negative. That variable is coming in line with the trend. So when you see these betas, now you have to start seeing whether the betas are in line with the trend that you have seen. Okay. Now let us see this one, number of credit transactions. What is the trend? It's a positive trend. As my credit transaction increases, my response increases. My log odds is increasing. Because my log odds is increasing with number of credit transaction, beta should be positive. Is my beta positive? Yes. Score. Score variable. We have that variable. So for score variable, this is the trend. As my score is increasing, my response rate is increasing. So beta should be positive. So I have to keep seeing, when I build model, I have to keep seeing this holding period imputed. This is the graph. So this is what, when you build a logistic regression model, this is the first check you have to do. Are betas in line with the trend? If the betas are in line with the trend, all okay. if you recollect when we did linear regression, logistics is a transformed linear regression. We had expense increases with income, expense as a function of monthly income, we had positive, expense as a function of annual income, positive. But when we brought both the variables together, we saw that for monthly income, the beta was positive. For annual income, the beta was negative. If there is a multicollinearity problem, quite often the first identification of that multicollinearity problem, even without seeing correlation matrix, even without seeing the VIF, without seeing tolerance and all those other things, the first level of identification of multicollinearity can happen from this point here itself. If the beta is not in line with the trend that you have observed, it is quite possible there is a multicollinearity problem with your variables that you are passing. Okay. Now, how do you see for categorical variables? How do you see this betas for categorical variables? The way it has to be seen is, let us put some numbers, table. Basically, I'll use my data dollar occupation imputed and my data dollar target. This is the output of this thing. Let us take this output, and again this kind of chart which I have done for continuous variable, similar graph you have to create for categorical variables also. That is your homework. Write a function by which you create similar chart for categorical variables automatically. Okay, for now I am taking this manual way. I'll put it here, data is text to column, okay. So this is target 0 and 1. So I'll do total equal to sum. What is response rate? Is equal to responders divided by, in this segment, home. So now if this is the trend of all these 5 categories, for which categories you should have the highest beta? For which of these categories you should have the highest beta? Yeah, online people, for which of these categories? Self. Yokesh, for which category you should have the highest beta? Self-employed. So for self-employed you should have the highest beta. See, when the trend is like this, the beta has to be positive. When the trend is like this, beta has to be negative. When there is a, with increasing value, the response increases, you need the higher beta. So here I want positive beta for this. Yeah. So this should have a higher beta of all the other categories. Which should have the lowest beta of all the other categories? SENP. lowest beta of all the other categories. Yeah, this should have relatively higher beta compared to SENP. SAL should have a relatively higher. Prof should have relatively higher beta compared to SAL. Missing should have relatively higher compared to Prof, and self-employed should have highest. This is the way the beta should come. Yeah. Now, if this is the way the beta should be coming, let us see what are the betas that we have got. So now what you have to do is you have to copy these numbers. Let me copy these numbers on Excel because all these numbers are in scientific format. So let me take them here. Data, text to columns, delimited, next, space, finish. So now I've got these betas. Let me convert them into decimals. So this occupation imputed, this is the column name and then the categories. Self-employed has got 0.10, which is the highest. Okay. So this is okay. The next one, is which one? 4.48 missing. Missing is not shown here. Missing is not shown. What did I say? Missing category, whichever category is not shown. If there are 5 categories, 4 categories will be shown. There is one category not there. If that category is not there, what is the beta of that category? 0. So I can say the beta for missing category is 0. Okay, 0.0. Okay, it's showing a hyphen, not issue. So is this the next best highest beta? Because all of them are negative, so it is. So this is also okay. Which is the next category for which you should have the beta? Professional. So professional is this one. Better, okay. This beta is also okay. Then which category? Salaried. Salaried is -1.4, okay. Then finally is self-employed. So betas of all these variables are also in line with the trend. Are you getting? So when you model, when you do this modeling, when you get this output, the first step you have to see whether the variable is significant. These all variables are significant. Yeah. Second is, are the betas in line with your trends? From visualization you got the trends. Similar visualization I said you have to do for categorical variables also. From visualizations you get the trends. Then you have to see whether the betas are okay. The third element in this, before you move forward, is there a possibility of beta changing sign? So what you have to do is, you have to take this beta, do plus or minus this number. So let me take this entire output in Excel. What is standard error? See, this is estimate. This is estimate and this is standard error. Whenever you are having an estimate is always a point estimate. If I take, say, 100 students of class 10th and measure their height, and the height comes out to be 5 feet 7 inches. Now I take this class 10th A division and height is coming 5.7. If I go to 10th B division, will the height be exact 5 feet 7 inches? No. There will be plus or minus. So whenever you are taking a mean estimate, that mean always has got a range, right? So what this is saying is this is my estimate of these variables betas, but there is a range. The beta can have a plus or minus impact also. So that is given by standard error. But now this range should not be too wide such that it is becomes unstable. So what I need to see is that too wide. So let us put it them in not in a scientific but in a decimal format. Now this is too small a number, so let me increase it. Can you see this? This is negative 5 times 0 and 4. But this is negative 6 times 0 and then 5. Which means the range is 1/10 plus or minus. So if I do, what I need to do is standard error estimate plus standard error to see whether sign change will happen. Likewise, I have to do estimate minus standard error also. I have to do see both of them, plus or minus impact. So here I'll do this calculation equal to, if I do plus, there is no sign change. If I do minus, there is no sign change. Okay. So sorry, it has to be, I need to do some constant. I know equal to, not constant, I need minus this. No sign change. Okay. Let us do this for all of them. Is there anywhere any sign change? Negative, negative, this is negative. No change. Positive, this is positive. Positive, positive. Negative, negative. Negative, negative. Negative, negative. Negative. This is 0.10 and there is a small sign change. Which means self-employed estimate is slightly dicey. It's slightly dicey, but can I tolerate this? In this case, probably I may say yes. Why? Because it's a categorical variable. And it's a categorical variable. In that range is self-employed beta at all given point falling between the other categories in the based upon our response rate. What was that? We saw this self-employed should come after missing, right? So if I do plus or minus, when I do plus or minus, is this going to be out of the other range? We have to check that. And quite possibly what it may happen, there is a missing element also. Missing is 0. Missing is 0. Missing is 0, I don't know. So it is quite possible that this self-employed may overlap with missing. Because missing is 0. Yeah? What can be done to ensure that stability of this is there? I don't want this instability should be there now. What can it be done? For all other things, it's stable. Only for now, this one particular thing, there is an instability. Because it is already 6. I leave this as a homework. What we can do to ensure that there is a stability. So this is another homework that you have to find out how to ensure stability of this variable. So there are 2 homeworks for our coming week. Yeah. One is the visualization I have made is for the continuous variable. You have to write code for categorical variables. Second is, I see that the stability of the beta estimate of the self-employed category, there is a sign change. What I can do to ensure the beta estimate of self-employed is also stable. Okay, with this we will call it end of today's session.
Can you share the updates and Excel?
Thank you. Any questions?
Can you share the updates and Excel?
I'll definitely share those Excels, all these things, visualizations that we have done. I'll definitely share. If there are any questions, let me know. Otherwise, we'll call end of the session. Thank you. I hope all of you enjoyed the session. Thank you. I am disconnecting now. Bye.